สวัสดีครับ
สวัสดีค่ะสวัสดีแขกผู้มีเกียรติทุกท่านอีกครั้งหนึ่งนะคะและต้องขอต้อนรับทุกท่านค่ะอย่างเป็นทางการเลยเข้าสู่งานมหกรรมอวกาศแห่งชาติประจำปี 2568 ค่ะ Thailand Space Expo 2025 นั่นเองนะคะแล้วขอสวัสดีผู้ชมผ่านทางไลฟ์ด้วยค่ะวันนี้ทุกท่านอยู่กับดิฉันค่ะเชอรี่พันศริบางประภากร
ผมท็อปคณิตวานิกมลนันท์ครับ
วันนี้เราสองคนรับหน้าที่เป็นพิธีกรนะคะซึ่งต้องบอกว่าครั้งนี้ค่ะวันนี้ของเราเป็นวันแรกซึ่งงานของเราครั้งนี้จัดขึ้น3 วันค่ะตั้งแต่วันที่ 16 ถึง 18 ตุลาคม 2568 นะคะณ True Icon Hall ชั้น 7 แห่งนี้ค่ะ
Very good morning, ladies and gentlemen, distinguished guests and member of the press, and everyone who watching online as well. Welcome to the Thailand Space Expo 2025. This event is held here since 16 to 18 October 2025, and you stay with me, Top Kanit, go along with my co-host.
And Cherry Pansri Bang Prapakon.
And both of us will be your master of ceremony throughout these 3 days.
ซึ่งในงานครั้งนี้ค่ะเรามีกิจกรรมมากมายเลยนะคะไม่ว่าจะเป็นหัวข้อเสวนาที่น่าสนใจที่เรากำลังจะเริ่มขึ้นในไม่ช้านี้ค่ะทั้งที่เวทีด้านในแล้วก็ทางเวทีด้านนอกก็มีเช่นกันนะคะรวมถึงกับช่วงของ business matching นะคะการจับคู่พูดคุยด้านธุรกิจค่ะรวมถึงกับบูธจากเราบรรดา exhibitor จากหลากหลายประเทศมาร่วมกับเราในครั้งนี้นะคะนอกจากนั้นค่ะเรายังมีเจ้าภาพจัดร่วมกับเราครั้งนี้ด้วยนั่นก็คือ JAXA PTT CP EGATและไทยคมนั่นเองค่ะ
Yes, exactly. In our event, there are a lot of activities we conducted on the stage, including the keynote with the interesting topic, many panel discussion, also the business matching, and including the booth from many countries. And thank you very much for our lovely co-host, JAXA, PTT, CP, EGAT, and last but not least, Thai Com.
และในช่วงเสวนาหัวข้อแรกเป็นอะไรคะคุณท็อปคะ
So the very first topic for today it is maximizing the value of AI and free satellite data. And first of all, give it up for Mr. Calvin Wang, lead product manager, come up on the stage.
ขอเรียนเชิญค่ะ
Hello, hello. Good morning, Bangkok. Maybe before we start, can I get a show of hands for those of you that took Grab to this event this morning? Anyone else? It's always nice to be amongst friends and potential customers. Oh. Okay, screen's all okay. Cool. So a quick introduction. My name's Kevin. I'm a product manager at Grab Maps. And before I get in here, what I'll talk today is a bit more about Street View imagery and AI. And I thought it's a bit more interesting because at Grab, we do a lot more like Street View imagery collection. And that's going to be the topic around today. Firstly, a little bit about what is Grab Maps. So Grab Maps essentially is the map-making division under Grab. We essentially produce the data, the services, the experiences, anything related to maps within the Grab super app. So for a lot of people, they don't know this, but a lot of Grab's core experiences are served through geodata. So for example, when you're selecting pickup and drop-off points, right, that's using our point of interest addresses, point of interest database. When you're seeing a route rendered on the super app, the routing, the base map data, and all the traffic on there is based from Grab Maps. When your driver is driving to your destination, right, the in-app navigation, the navigation SDK is produced by Grab Maps. And if you're looking for nearby restaurants, nearby locations, the point of interest, map tiles, all the opening hours, menus, that's produced by Grab Maps. So that's kind of who we are, what we do for Grab. Now, the reason why we decided to start making maps from 2017 was because when we had a look at all the mapping providers in this region, what we realized was that it wasn't really serving a lot of the needs of this region. So for example, there are some POIs that are not really on roads. There are a lot of businesses that are served from alleyways where traditional mapping vehicles cannot access. And this region also, things happen all the ways on the real time, right? So sometimes a flood could happen within minutes of notice. Sometimes traffic changes all the time, right? As we know in this region. So we really needed something to serve the needs of this region. So since 2017, we have built our own map stack. And several years later, we're one of the only ride-hailing and food delivery companies in the world that have our own end-to-end mapping stack. But coming back to imagery and AI, which is the core topic for today's conversation, right? So how it works today, what is the status quo? Just for a quick recap. We'll start from, firstly, high-definition imagery collection. So we have a hardware team, naturally out of Shenzhen, China, where we build our own high-definition cameras. And when the imagery is landed in the database, it then goes through several machine learning pipelines, right? So you can imagine one pipeline for detecting street signs, one pipeline detecting how wide is a road, one pipeline detecting what is the street name, for example. Once these detections go through these machine learning pipelines, then some of them will be high confidence, which goes straight onto the production map. Some of them would then need some validation from our large map operations teams, who then kind of checks to see, okay, this one is good, this one is not so good, and to make sure that the data that we go on to the production map is highly accurate. Just to make it a bit more visual, right, this is a snapshot from one of our internal tooling. So when the image is landed in our database, it is being checked. So in this case, there is a no right turn being detected, and our map operation team is validating whether or not it is correct and should go on the map. And where it's added to the map, it is matched to a road, and then going forward, all the route engine going forward would account for this no right turn at this intersection to make sure that the routing doesn't route drivers against this illegal turn. So that's roughly how everything works today in the status quo. Now, having set the stage for how things work today, now the more interesting things. Give me a show of hands if you remember this moment. Yeah? So this is the moment when Steve Jobs unveiled the iPhone for the very first time. And our times are forever wasted. So basically, what I really like about the way he breaks down this problem space is that he had a two simple axis, right? The point he was making was that the traditional smartphones of the day, they were not so smart, but very, very hard to use. And the old school phones like the Nokia 3310, they were not so smart, but they were not so easy to use as well. So iPhone is on the top right corner, where it's much smarter and much more easier to use, right? And thanks to Gemini, I was kind of asking Gemini the other day in prompting to say, hey, can you help me reproduce this axis, right? So basically what we reproduced was a two axis, but more for imagery detection. So on one axis, we have real-time imagery to batched imagery, right? And you got to forgive the AI for misspelling here. So on the traditional imagery axis, what you used to have is these really expensive map-making vehicles, right? These are street view imagery collection vehicles. I think back in the day, it used to cost like $200,000 per vehicle, where we cannot have real-time imagery collection because these vehicles are very, very expensive. You can only make like one round for one road once every year, and for a lower tier city, probably once every 2 or 3 years. And the aspiration is how do we move towards more real-time collection of imagery, right? Because the fresher, the better. In this region, things change all the time. If you do not have the fresh imagery, you're going to miss things as it happens on the road. On the vertical axis, we have flexible versus not so flexible detection. In the current status quo, I think a lot of folks here are fairly familiar with a high level of a machine learning process where just to have a pipeline that detects, for example, cats, you need to label thousands and thousands of images of cats, and then it goes through a machine learning team for about 3 or 4 months, and then at the end of it, you have a pipeline that can only detect cats. But what if you then need to detect dogs? What if you need to detect garbage bin overfills? What if you need to detect infrastructure? You need a new model for every single new type of detection. So the aspiration here is, what if we move towards a very flexible model which can do any kind of detection we want, right? So the aspiration for this top right corner is if you have real-time imagery that's really watching what's going on the road all the time, and you have a detection capability that can detect anything you want, right? So then you can do really fancy use cases like, tell me how long is a queue at a restaurant at any point in days, right? Because you have super high freshness and you have the ability to detect any kind of intelligence that you want to. So what is in this space, right? What is in this aspirational dream state? Now let me break it down one step at a time. So at Grab, firstly on the horizontal axis, we invest both in active and passive collection. So what is active collection? Active collection is when we send somebody with the intention of collecting imagery. So for example, when we send our drivers to a remote road somewhere, they are there for no other reason than to collect imagery for that road network for us. Passive collection, on the other hand, happens in the background. So the driver could be on the way to picking up a passenger. They could be on the way to dropping off a mart. And if we have the edge hardware devices deployed in the fleet vehicle, then we can passively collect what's happening on the ground as the jobs are happening. And the benefits for this from a real-time collection perspective is obvious, right? So in the past, you have these very expensive hardware that's collecting once every year. Now you have this dash cam deployed, and if you look at, for example, the road in front of this event venue, you can imagine several Grab drivers are passing by this every day, right? So having the edge devices, dash cams deployed on device would ensure we have much fresher imagery. Now the vertical axis, which is the flexible detection axis, right? What we're seeing is that there's a lot of advancement in imagery text multimodal model in the recent years, even though technically these models were developed before the generative AI revolution, right? So I think the technical term for these were CLIP, I'll give it a best go, contrastative language image pre-training, which is a really fancy term. Essentially, when I asked my data science team, hey, what does this actually mean? It basically means models where image and text are inputted as training as a pair. So for example, you have Apple here, the image, and you have Apple here as the text, right? And these two things are correlated, and they enter into model training as a pair. So when you throw 400 million of these pairs into a model training, what you end up with is a model that understands image and text extremely well. So when you then run these inference from these models on street view imagery, what you get is you can implement something like a real-time universal language search on the street view imagery. So let me just show you what I mean here. So this is a prototype we've built in the back end. And see if the image will play. Oh, it's playing. So essentially, you can search for things like accidents, and you return all the locations of street view imagery where accidents are happening. You can search for flooded streets, and you return all areas of the street view imagery where streets are being flooded. And remember, what's happening really in the background is all this imagery is being sent through these image text models, and it's creating an embedding, which has a very similar distance to an embedding generated from the text string, because the model understands text and image well. So the embedding vector it generates is very close together on the coordinate. So the potential for this is very high, right? So you can search for Teslas, you can search for orange juice machines, whatever strikes your fancy. Because these models are just trained with a very diverse set of image text pairs, so it's able to understand image and text very well. Oops. So I guess at this point you can ask, hey, Kevin, so you've talked about dash cams, you've talked about flexible models. Does this mean mission accomplished? And that's a hard no. And this for two reasons. The first reason is we cannot afford to upload all the dashcam videos and images onto the cloud. One, the internet bandwidth wouldn't allow it, and two, we simply cannot afford the cloud storage cost and processing cost on processing all the imagery available, right? So that cannot happen. So the second question is, what if we just run these large models on device, on the edge? And mind you, like our hardware KDC device do have a very, very powerful and expensive chipset on there. Having said that, it's not able to process the full image text model, because that's just something that you really need something like a cloud server to do. So how do you handle this problem? So the best thing we've come up with, and just sharing here and open to more brainstorming and for discussions as I meet you throughout this conference, is what we call a big brain, small brain duo. So the big brain sits on the cloud. It has a lot more compute. The small brain sits on the dashcam, it has a lot less compute, but it's mobile on the device, on the fleet device. So when we want to detect something, for example, you want to detect, what's a good example? Apple trees in Bangkok. You would send this task to a big brain. The big brain will create the embedding for what it needs to detect. You'll send the target embedding to the small brain, to the dashcam. So now the small dashcam knows that I need to search for apple trees, right? Which is the thing I need to look for in the embedding format. And what the small brain has on its device is a hyper-distilled model of the big brain. So it's able to kind of understand what apple trees are like without having the fullest precision recall of the big model, right? So what the small brain then is doing on devices, on the dashcam devices, is as it's driving through the road, is turning everything that it's seeing from the dashcam into embeddings and constantly comparing against the target to see, hey, does this look like an apple tree? And wherever it's seeing something that looks like a target, it will send both the embedding and the image back to the big brain for final processing. So what the big brain will see then is, so this vehicle this afternoon is seeing 10 things at these 10 locations which look like apple trees, right? Let me go through them, have one more pass through my full-size model to see if they're indeed apple trees. So then what the big brain might see is, this is a cloud server, might see is, okay, out of all the 7 detections that the dashcam saw over this afternoon, maybe only 5 of them are really apple trees, the 2 are banana trees, for example. So then we have the final detection, which is the 5 apple trees that this vehicle has detected in one afternoon. So how does it look like in real life when we apply it to practice? So if we have a driver reporting that, hey, guys, there is a temporary road closure here, have a look at it, right? The big brain will quickly create an embedding for what a temporary road closure looks like and dispatch that to all nearby vehicles in the area. So all the dashcam now is on the lookout for what is a temporary road closure. When it sees something that looks like a temporary road closure, you will send that embedding and the image up to the big brain into the cloud to see, hey, is this actually a temporary road closure? And the cloud would then see, yes, it is a temporary road closure. Please map it to the production, right? So in some cases we have tested, we can close this loop within 7 minutes, which is a big improvement compared to in the past where we have to collect imagery over like every year, and then in that time, maybe the road has opened and closed maybe 10 times already, right? We'll never know because we don't collect to that point of freshness. So that kind of brings me towards the end of this presentation. I do note that the key agenda of this topic is about free imagery. So just wanted to call out that, at Grab Maps, we do open source some, and we do partner with B2B partners to monetize most of our Street View imagery. So if you're keen for partnerships, please do speak to us after the session. And with that, thank you very much for your time.
So thank you very much, Mr. Kevin Wang, for your insightful sessions. And we do hope everyone gain a lot of beneficial from the sessions as well.
นะครับผมขอบพระคุณมากคุณเควินบังครับซึ่งเป็นพาร์ทแรกคุณของคีโนตนี้ซึ่งเราฮาฟไว้เดี๋ยวอีกสักครู่เดียวจะมีอีก2สปีกเกอร์ด้วยกันที่จะมาบอกเล่าเรื่องราวหัวข้อเดียวกันเลยนะครับแต่ก่อนอื่นเลยเราขอไล่เรียงนิดนึงดีกว่าว่าในงานของเราเนี่ยตลอดทั้ง3วันมีอะไรกันบ้างเริ่มจากในฮอลล์นี้เลยดีกว่าคุณ
นอกจากเสวนาบนเวทีนี้ค่ะเรายังมีนะคะเราบรรดา exhibitor กว่า30หน่วยงานแล้วก็หลากหลายประเทศมากๆเลยมาร่วมกับเราในครั้งนี้นะคะ Thailand Space Expo นั่นเองนะคะทุกท่านสามารถใช้เวลาในระหว่างช่วงเสวนาเนาะได้ไปชมกับแต่ละสถานที่แต่ละ exhibitor ได้เลยนะคะร่วมพูดคุยแล้วก็สามารถมีช่วง business matching ด้วยนะคะสามารถพูดคุยต่อถึงโอกาสทางธุรกิจในโอกาสถัดไปได้อีกเช่นกัน
ใช่เลยในโซน business matching จะมีทั้งด้านในฮอลด้วยแล้วก็ภายนอกฮอลแต่ภายนอกฮอลนี้ได้ข่าวว่าโคโฮสมากมายเลยไม่ว่าจะเป็นในส่วนของแจ็กซ่าก็ดีปตทนะ CP EGAT แล้วก็ไทยคมนะครับซึ่งเป็นโคโฮสของทางจิสตามาตลอดนะครับผม
ซึ่งต้องบอกว่าจริงๆแล้วครั้งนี้ค่ะเราเป็นการเปลี่ยนชื่อครั้งแรกปีแรกซึ่งจริงๆแล้วถ้านับรวมๆกันเนี่ยปีนี้เป็นปีที่5เป็นวีคที่5แล้วค่ะคุณท็อปค่ะ
ซึ่งต้องบอกว่าแต่ก่อนเนี่ยชื่อ Thailand Space Week เนี่ยผมเองได้มีโอกาสทำ Thailand Space Week 2024แล้วครั้งนี้เขาจะทำให้มันเป็นมหกรรมที่ยิ่งใหญ่ขึ้นเลยเปลี่ยนเป็น Expo
แทนนะคะซึ่งก็ถ้าพูดเป็นวีคก็คือวีคที่5นั่นแหละ เชื่อว่าหลาย ๆ ท่านนะคะอาจจะมีโอกาสได้ร่วมตั้งแต่วิก1 ปีแรกของเราทุก ๆ ปีค่ะเรามีการจัดที่ยิ่งใหญ่ขึ้นมีการจัดที่เรียกได้ว่าพัฒนามากขึ้นนะคะ
เอาละครับผมแขกท่านผู้มีเกียรติครับเดี๋ยวเราจะนำพาทุกท่านเข้าสู่ช่วงเซสชั่น1เหมือนเดิมในครึ่งหลังนะครับผมในหัวข้อ maximizing the value of AI and free satellite data นะครับเรามีทั้งหมด2 speaker ในช่วงนี้ครับ so there are 2 speakers on this half back session as well first of all I would like to invite Miss Hana Maniso Director of Cloud Engineering Google Map by Go Pamelo and Mr. Adam Raif Engineering Manager of Google Maps by Gomelo.
A round of applause please
สวัสดีค่ะ
สวัสดีครับ Good morning everyone
Hi good morning everyone I'm Hana Maniso Cloud Engineering Director from Copomelo and I'm joined today with
I'm Adam and Head of Pre-Sales at Gopamelo as well Nice to be here
Hi we are Copomelo we are senior premier partner service from Google นะคะ so today we are here to discuss about maximizing the value of AI and free satellite data using Google Cloud solution For the integration of this powerful platform, we are to share you about how we are doing in terms of like address the global sustainability and for the environmental challenge.
Right, so we'll start off with a summary of Google Earth information and we'll talk about the top 5 use cases you can see on the screen here. And at the end, we'll outline how to get started if you were to be interested in some of our technology.
For the Google has been a pioneer in like geospatial technology over 15 years old. We are first launch is about the Google Map and Google Earth about 2005 and in like from the additional feature that we are coming we have like launched the live traffic and street view and for in progress in terms of like many paper in terms of scientists paper for first time press and global forest watch paper in terms of the public information for the big milestone is about like for the earth engine we have launched in terms of like commercial use we have like 4,000 new city apps and about like 1,000 data sets Google Earth Engine have a long history for enable the environmental and social impact. Example like Global Forest Watch, they have like for the data technology and to empower people everywhere can be better protect the forest. For the U.S. Forest Service also, they also have like for manage in terms of like mission critical task for the month 2 hours. And for the company like Unilever, they adoption about the about the from the palm oil supply chain. So this one they utilize an adoption about the spatial data adopt in the business. From this one is mean about the a lot of the data from the satellite have the high resolution global map of 21st century forest cover chains. Is manage a lot of the data like 654,178 Landsat scene is about 700 terapixel of the data. This is require the compute more than 1 million of the hour of the computation and 10,000 of CPU use. Yeah, it can provide and manage analyze just only 4 days. But if we use this kind of the huge data under only one computation, it took a time about like 15 years. So this is the critical of the speed you see. When we have a lot of the data, we require the high computation. How we can manage? Because we need a lot of the classic remote sensing for the workforce. It consume a lot of time for data scientists to be infrastructure and data preparation, including provisioning infrastructure, including downloading the data managing about the auth file format and dealing with the metadata and correct about the bad and missing the data that we need to involve for the cloud and shadow and atmosphere. This kind of thing under the Google Cloud technology, they can prepare and handle it for you. 90% of your consuming the time can done with the Google technology. So that is mean you can consume the time back to your life to focus from the thing that you have specialist in about data scientists. For the both technology coming with the Google Earth and Google Cloud. Google Earth come from with over 10 years about sustainability impact with the NGO, academic and researcher. Google Cloud coming with the mission to be every organized ability to have like digital transformation. For both of technology together, you can doing in terms sustainability and transformation within your industry.
Right, so Google Cloud just doesn't rely on one single solution, but rather integrated platform of different solutions. So when you look at geospatial data, you kind of look at two main factors of data, which are mostly your vector data and your raster data. So vector data, you can imagine data that's just structured in a table format, and we use something called BigQuery for SQL analysis on those vector data. When you look at raster data, we then, or satellite imagery data, we use Earth Engine, right? And on top of that, we have Vertex AI, which you can build machine learning models to help do analysis on those data. And then you can deliver those insights onto a very familiar interface that we all know, Google Maps, right? And for your teams to use these tools or ecosystem, there's open source JavaScript or Python as well. So it's very familiar tools that everyone or developers can use. Right now, if we look at one of the more important industries in Thailand, agriculture, this is how we maximize the intersection of geospatial data, right? On the left, you can see multiple data sources. So your public data, your partner data, for example, even from GISDA, private data from crop data, your crop yield data, or even government land data, you can ingest that into Earth Engine or Google Cloud. And then we use two main components here, Earth Engine analysis and also Vertex AI, right? Like I mentioned previously. And then we can then push it to data products like Looker Studio, which is an interactive dashboard tool provided by Google, or even create custom applications for your farmers, for example, to send alerts to them on a mobile app. Right? And what's the magic behind Earth Engine? It's just pure parallel computation, right? So that's where it slices and dices your mapping and reducing as well, your mathematical models. And it uses all this data to do machine learning as well. Right, so how do we access Earth Engine? Through a supercomputer? No, it's just through a simple web browser, right? You can literally put in your script, write your code, and then run that data, and it produces a reiterative cycle that's very easy to repeat, refine, and perfect. And you can also share and publish it with your colleagues as well, so it's very productive. And again, I like to repeat that it's very accessible as well. A lot of developer tools and open APIs and client libraries are available. A lot of tools like PyTorch or TensorFlow, these are all familiar tools that your teams will not have to learn or relearn, right?
Yeah, thank you, Kun Adam. For this one, we already understand what is the foundation of the product from the Google Earth Engine and Google Cloud. This kind of the performance from the both leader of the technology from the satellite data information and for about cloud that you can use to be compute and processing your data. You not suffer in terms of you have like the data, but in terms of how you can produce it to be the value in the real data that the business that looking for. For this kind of thing, we can be the show what is the every industry can adopt this kind of the technology, both sides of the technology to be the business value. Okay, for this one, today I will show you about how to adoption the satellite data and AI from the Google solution for the industry Today, I come from the use case for 5 use case that relate with the industry, right? Retail, CPG, manufacturing, edtech, digital native, even financial service, insurance, logistics, real estate, or public sector, for or oil and gas. So today, we will deep dive what is the solution adoption for each business.
Right, we'll take a look at our first use case, again, sustainable sourcing for agriculture. The main problem here is due to legislation or EUDR legislation for deforestation, right? So it's one of scale, and the solution using Earth Engine is quite simple. You use Earth Engine to geolocate all the farms in the supply chain, and you run an automated analysis on the satellite data to detect those forest loss after the 2020 year cutoff date, right? Now, deforestation isn't just as important as water stewardship or sustainable use of water. Right? There are 2 key questions to kind of answer for this. So what is the past impact that water stewardship has, and where is a safe future site for storing water? All right, so Earth Engine also provides you access to JRC data for the first question, and also site selection for map rivers to apply some buffer zones just to make sure to ensure a safe distance for your safe water sites.
For the next use case is about climate risk and disaster response. From the climate risk and disaster response, the industry will be related like a logistic, real estate, financial service. The company that involved think about the climate risk for operation and manage investment, and for the public sector also that you need to respond in term of manage in term of like many incident and how to involve in term after incident to maintain the nature of the country also. The problem of this kind of the solution is very complicated to understand about the climate risk that will require the data need to up to date, the data size and combination about the infrastructure, how to access the risk, how to get the data in real time like a fire, some place, how you can forecast what it will be scaled out or make a damage for some site. So it is the required for the solution Google Earth that can provide the data scientist, engineer, policy maker, financial institution in terms of response for the agency to have like insight of the data, monitoring about the Google, about the flood and about the fire or drug or some smoke that they can detect with the Google satellite. For the monitoring and modeling fire, they can detect in terms of fire in near real time. This is the information, the data says is available for analytics in the Google Earth for the imagery from the fire early detection and fire information for the resource management system.
Right, we'll move on to our third use case, agriculture. When we look at agriculture, we kind of face a dual challenge. We want to produce more food, but we also want to have less impact on climate change, right? So the solution here from Earth Engine is to use something we call precision agriculture. It performs pixel level analysis at a scale using satellite data from Google Earth, right? And it delivers insights and can predict crop health, soil moisture, and increase your crop yields while reducing your environmental footprint of the earth. Right, so your Earth Engine can also model future climate scenarios and impacts, and it contains climate projection data sets like NASA's CMIP6, right? It predicts shifting rainfall patterns and also identify coastal farms at risk. So all this data can be used by your policymakers or your governments to predict climate scenarios.
Next, for the fourth use case is about to protecting the natural resource. The public sector need to manage and maintain in terms of like responsibility for host for registration to protect the natural resource like forest, water, and minerals. The problem is about how to understand the complex interaction between ecosystem and the long-term consequence for the resource that is very challenging. The solution Google Earth, we have like the data consequence policy maker to monitoring and manage what is the activity include like sustainability for forest management, monitoring about the land cover change, about the land ownership, and about to forest management that can be to manage and monitor in each country. That we know the data we can monitor, so that it means we can have the activity or action to protect or have something that to be improved. For the forest change monitoring and analysis, under the Google Earth engine side, we have the model for the data. We can rely and play around for this kind of the model and AI solution for that one to analyze the forest change, to quantify the forest change over time, and can be create the charting yearly forest loss. So this one is about forest monitoring for action that you can be filtered by the data set and calculate alert within specific area of interest from your business.
And for our final use case, environmental impact, we focus on methane emissions. So methane is a common greenhouse gas, and it accounts for 30% of all greenhouse gases. But the problem is sometimes we don't know where emissions or leaks of methane come from, right? And if we're using Earth Engine, you can use our methane satellite, our methane SAT, with processing power of Earth Engine that allows physical surveys to a near real-time monitoring system for methane emissions or leaks. Right. So in a broader sense of picture, we have Earth Engine that can detect environmental change and impacts, and you can see the animation on the screen that shows Lake Pupo in Bolivia drying over 30-year period.
Okay, this is how when we already launched the Google Earth in terms of the commercial use, how you can get started to use this kind of the solution. So the first one that we can tell you about the step to start is about the first one, access your current state, access your technology, your current technology, your data, your people. What you have now, and you can identify the scope of challenge that is will be aligned for your business looking for. Second one, you can choose a use case based on your have done in terms of the assessment, and you finding the showcase that can give benefit to your business to utilize Google Cloud and Google Earth in your adoption. And the third one is about select the deployment station, evaluate and select partner like GoPomelo that can support you in terms of like we have expertise and we can onboard you for the Google Cloud solution, and we have the engineer to have the certified to know well about the Google tool. And the fourth one is about check the prerequisite. When you go and join for the onboarding, sometimes you need to check about like your compliance, your business requirement, what it you need to prepare and aware before you utilize this kind of the solution. And the last one, delivery a POC. When we grab everything inside our place, we can evaluate what the solution from the Google Cloud. This is the fit and valuable from you. This cloud service is pay per use pay only what you use. So this one is mean cost saving, speed and reliability, and you can scale it out. So when you bring all of these kind of things to your business, you can solve the first value for adoptions, satellite of the data and AI inside of the technology from the Google Cloud.
Thank you, everyone. I hope you enjoyed our session today. Thank you.
Thank you.
Thank you very much, Ms. Hannah and Mr. Erdam from Google Map by GoPomelo for your insightful session.
ขอบพระคุณมากครับตัวแทนสำหรับในส่วนของคีย์โน้ตแรกเลยเป็นไงบ้างคุณเชอรี่
โอ้โหต้องบอกว่าเป็นความรู้ใหม่ที่อัปเดตในปีนี้จริงๆนะคะแล้วก็นอกจากกิจกรรมต่างๆนะคะในงานของเราในฮอลล์ของเราแล้วด้านนอกค่ะหลากหลายบูธเลยค่ะคุณท็อปผา
ไปไหนมาบ้างแล้ว
เมื่อกี้
เห็นมาถ่ายรูปมา
แบบแอบไปสัมผัสอวกาศที่ CP มา
ยังไงอ่ะ
คือเขาเป็นแบบคล้ายๆเป็นอวกาศเป็นสเปซให้เราไปเหมือนว่าเราได้เดินทางไปอวกาศแบบนั้นเลยค่ะ
แบบล่องลอยใช่ไหม แล้วก็เมื่อกี้เห็นมนุษย์อวกาศตัวใหญ่ด้วยถ่ายรูปได้นะแล้วก็นี่มนุษย์อวกาศตรงนี้ที่อยู่ใกล้ๆคุณเห็นไหม ตรงนี้
นะคะ
แลนด์มาร์คของงานเลยนะ
แน่
คุณ
น
ต้อ
อง
ไป
น
ถ่ายรูปกับเขาด้วย
มาถึงก็อย่าลืมถ่ายรูปเช็คอินกันก่อนเลยนะคะ
เอาละครับว่าด้วยเรื่องของคีย์โน้ตต่อไปนะครับผมซึ่งเดี๋ยวไล่เรียงให้ฟังนิดหนึ่งบนเวที
ได้ค่ะ
ของเราเมื่อกี้หัวข้อผ่านไปเรียบร้อยแล้วคีย์โน้ตแรก maximizing the value of AI and free satellite data คีย์โน้ตต่อไปก็สำคัญเช่นเดียวกัน เพราะว่าเป็นเรื่องของ from lab to a rocket จรวดร็อกเก็ตคุณมีความรู้ไหมเกี่ยวกับเรื่องร็อกเก็ต
วันนี้แหละค่ะ คิดว่าน่าจะได้รู้เพิ่มเติมมากขึ้น
Guys, ladies and gentlemen, our next keynote is going to be the topic of from lab to rocket towards 100 times growth business. So I would like to invite Dr. Sandy 30, please join us on the stage.
Big round of applause please
Good morning. Thank you very much. My name is Sandy Tirte. I've been at Rocket Lab for nearly 14 years. I'm actually the third employee after Peter Beck. So I'm very excited to be here today and also to talk about a different topic. Usually I go to conferences and I talk about the future, about what Rocket Lab is trying to do. But this time I have a bit of an opportunity to talk about how we went from point A to point B and where we are trying to go. So from day one, our vision has always been we build space infrastructure. We are called Rocket Lab just because that's the way we started. However, we've never seen ourselves as a rocket company or as a satellite company. We've always seen ourselves as a company that has the mission to deliver infrastructure for space. Once you have infrastructure, space becomes much easier. And so really we started on this journey in 2014. And from day one, we've started building. Our approach has always been building and testing. I joined in November 2013 as the VP of Vehicle Systems. So my role was to design and build the Electron launch vehicle. And when I joined in November, the rocket was going to be made in aluminum. In December, it's going to be made in carbon with a steel liner. And by January, it was going to be made fully in carbon. So as I said, we started building straight away. So what you see on the left was our test cell with the Rutherford engine. This is a very rudimentary test cell. And actually, what you can't quite see is just behind the test cell is the Auckland airport. So anyone flying to New Zealand would land at the Auckland airport, the largest airport of the country, and would see rocket engines being tested there. Don't repeat it, but we've set the airport on fire twice, just the grass. A few months later, we have announced the Electron program, which you see on the top left. But what you see is not a finished product. In fact, there was just a plastic mock-up. But we just made it clear to the world that this is what we're trying to build. And in parallel, we built the real articles. So this was just a few months after starting, a fully carbon tank. Very similar to what we're flying today, and undergoing cryogenic testing, pressure testing, so testing. The reason we are so focused on testing is that we want to be a hardware rich, and in fact, we're not the only ones. If you look at SpaceX, they're very hardware rich as well. Because once you build the hardware, you have something in your hands. You can analyze forever, but if it doesn't pass the building and the testing, it's not worth anything. Just 2 years later, so we obviously operated at a high pace, small team high pace. So by that time, we were probably a team of about 80 people. We were doing a first stack test. So what you see here is a facility we've built ourselves south of Auckland. With a tank that represents our fly hardware and the whole engine block that went for first launch. So quite a rudimentary facility, but really something that is adapted to let us iterate quickly and just demonstrate that we can run all 9 engines at full duration, at full performance, and that they're good for flight. In parallel, building the rocket is just 1/3 of the work. The other two-thirds are building the range and the regulatory aspect. The range is, this was the first version of the range on top right, so that was the first privately owned orbital range in the world that we built in Mahia. And so about roughly 3 years after starting, the rocket was there on the range and ready for the maiden flight. This took place in May 2017, and it went almost to the end. When I say almost to the end, it went through a successful first stage, successful separation, successful second stage, and it was actually terminated by a human by mistake just before completion of the second stage burn. So Rocket Lab was not in charge of the FTS. That had to be another group, and that was the FTS, flight termination system, was terminated. However, that was the best flight we could hope for because we had all the data we ever dreamed in order to continue developing the rocket. And so based on that partial success, we've been able to iterate quickly. So 2017, 1 launch. 2018, 3 launch successful, 1 test launch, 1 commercial, 1 government, NASA. 2019, as you can see, it accelerates. We went from 1, 3, 5, and just a good mix of half commercial, half government, demanding agencies like NASA, DARPA, US Air Force. So we've always been all about speed of execution. It's always been very important to us to have a healthy mix of client. So we've always kept a mix of about 50% commercial, 50% government. And in the 50% government, about 20% civil, 30% defense. Because we believe that this is the best mix. With commercial give you growth. Sometime you're going to sign a 10 launch contract like the one we've announced about a month ago with the company Inspective, which is right there actually. And so suddenly it's a large boost. This doesn't happen really with government. With government, you don't wake up one day and you have an order for 10 launches. However, with government, you see the programs that are coming and give you a very long-term map. So you know what to develop, you know how to develop your solution so that you can meet these programs. So keeping a good 50-50 is a good mix. Again, demanding clients as well. For example, we flew the NRO. The NRO had never flown outside of the United States before flying with us, and we brought them to New Zealand and flew them from New Zealand. Orange in New Zealand has always been an asset for us. We built this in New Zealand because with the range in New Zealand, we could launch every 72 hours. So we had the largest launch availability we could hope for. And these are just a few of the launches we've done. To be honest, it's a little bit of a feel-good slide. But some of them have been quite special. For example, the Capstone mission 2 years ago, where we launched the Capstone small satellite around the moon from New Zealand. So we demonstrated that you can do research beyond the Earth orbit without needing a large launch vehicle. You can launch around the moon, you can launch to Mars or to Venus with a small launch vehicle, and especially on a short timeline. So that mission was, from start to finish, was 3 years. So we're all about speed, we're all about accelerating. 2019, we've announced the Photon program. And that came from the fact that we realized every single time we launch a client, we have a satellite for free, which is our upper stage. So we could test satellite components, and we could also turn the upper stage into a satellite. Rapidly, we demonstrated the idea. In 2021, we had the very first Photon, and we've also announced the capstone mission that I discussed before. And quickly, the Photon idea became not just one satellite based on our upper stage, but a family of components that could be used for difficult and demanding missions, like the capstone mission. So if you look at this platform or that one, they don't have much in common. But the family of components is the same. So this one, compared to this one, have very large propellant tanks and very large delta V, and also all the components that are necessary for guidance toward the lunar orbit. Between 2021 and 2022, we became a public company, traded on NASDAQ, and that gave us a vehicle to perform acquisitions. So we acquired the company ASI that does satellite software, Sinclair, which is based in Toronto, that does reaction wheel and star tracker, Solar Aero in New Mexico, that does solar panels, and PSC that does separation system. And our criteria for the company we acquired was always hardware-based. So they need to manufacture really good hardware, good quality, but they need to be at a level where they cannot expand further. And so this is where we come in. So if we take, for example, Sinclair, when we acquired them, they were making about 20 reaction wheels per year. Now we brought it to about 1,000. Being part of Rocket Lab, we have access now to some clients that Sinclair could not have had before because they didn't give the insurance that they could manufacture at scale. So what we bring is manufacturing at scale. If you take Solar Aero, even before we acquired them, they had made the solar panels that were on the James Webb Telescope, on the helicopter that is on Mars. So really good hardware, but what we brought to them is scale manufacturing. Recently, we've announced that Rocket Lab is jumping also into the payload business. So until then, we were making satellite bus. Now we're jumping on payload. So with the acquisition of Geost, which does optical system. So today, despite the name Rocket Lab, 2/3 of our revenue come from satellite, the sale of satellite components or satellite system, the development of bus, which is exactly where we want it to be. That was our roadmap. Remember, our goal is not to be a rocket company or a satellite company, but space infrastructure. So today we are a leading manufacturer. We are vertically integrated, which allow us to do very varied, difficult projects, but at speed. So we've made 2 of these Escapade satellites that are going to be launched by Blue Origin to Mars in the next month. By the way, these satellites don't necessarily launch on Rocket Lab. This one launched on Blue Origin. This one has launched on SpaceX. This is the Varda capsule, which does orbital manufacturing of pharmaceutical components. And then Rocket Lab has made the satellite, has operated the satellite, and has commanded the re-entry of the capsule on Earth, where the pharmaceutical components have been retrieved. And this is the Lightning platform. We're building, from memory, about 38 of this platform. We have a $500 million US dollar contract with SDA, and a similar contract as well with the company that provide connectivity to satellite connectivity to the Apple iPhones. So some of our flagship mission, I talk about Capstone, I talked about Rivada. One thing that is not necessarily known to everyone is a few months ago, Firefly landed on the moon. However, the software that landed the lander is a Rocket Lab software, and in fact, our team was integrated with their team for the landing. I talk about flagship mission, about SDA, Global Star, and about Escapade. We also have a Victus Haze mission where we demonstrate We demonstrate orbital rendezvous and also a responsive space. So an object is going to be launched on orbit, and we're going to get a phone call, and within 24 hours we have to launch and do an orbital rendezvous. And finally, the next step, we are flying the Neutron launch vehicle this year. So where Electron can launch 250 kilo, Neutron can launch 13 ton. I've talked about a satellite platform. We've also introduced the Flatellite platform, which is a platform that can be mass-produced, and it's very flat, so we can stack them within Neutron. And the future for us is the combination of Neutron and Flatellite in order to rapidly deploy at scale a large constellation and our own services. So once Neutron is flying regularly, and once we have Flatellite in Neutron, then Rocket Lab can jump to the final stage, which is really infrastructure and basically applications. Thank you very much.
Thank you very much, Dr. Sandy, for a very useful and informative message from this session.
ขอบพระคุณมากครับ It is past already the second session for today but คุณเชอรี่ there are 4 sessions for today is remaining 2 Alright, the topic is very interesting as well, the space to thrive, Southeast Asia space industry on the rise, and the last session for today is a space 3.0 opportunities for Southeast Asia.
So everyone please stay tuned. So today we're gonna have a lot of amazing, interesting topic together.
Yes, and absolutely 5 p.m. in the evening will be the huge spectacular opening ceremony will be conducted on the stage over here as well เอาล่ะคุณเชอรี่
ค่ะ
ด้านนอกเรามาต่อกันดีกว่าได้ข่าวว่าโค้ชของเราหลากหลายใช่ไหม
ค่ะ
ไม่ว่าจะเป็น ECAT อย่างนี้ CP อย่างนี้
มาก็
ปต
มาด้
ท
วย
เมื่อกี้คุณไปที่ CP มาแล้ว
ใช่แล้ว
ก็
ค่ะ
พอๆเหมือนกัน ECAT คุณก็บูธยิ่งใหญ่เหมือนกันหัวมุมเลย ไม่รู้ว่าเขามีพลังไฟฟ้าอะไรมาช็อตเราหรือเปล่า
วันนี้เดี๋ยวอีกสักครู่เดี๋ยวช่วงเบรกเดี๋ยวเราจะไปชมให้ครบกับทุกบูธทางด้านนอกเลยนะคะ
ใช่ไหมต้องไปให้ครบเนอะอ่ะนอกเหนือจากนี้ในทั้งข้างในและข้างนอกเนี่ย
ค่ะ
มีโซน business matching หลากหลายด้วยกัน แล้วก็แน่นอนพาร์ทเนอร์ของเราเลยที่สำคัญได้ข่าวมามากกว่า 30
หน่วยงานนะคะซึ่งจริงๆต้องบอกว่าเพิ่มขึ้นแบบนี้ทุกๆปีเลยค่ะเชื่อจริงๆนะคะว่าปีนี้และปีถัดๆไปถ้าทุกท่านมาร่วมงานของเราอาจจะแบบเป็น30เป็น50อะไรแบบนี้เลยยิ่งใหญ่ขึ้นทุกปีจริงๆ
Ladies and gentlemen, without further ado, we're heading to the next session. The topic is the space to thrive, Southeast Asia's space industry on the rise. And in this session, we have 4 speakers. So I would like to invite Ms. Nicolette Yo, General Manager, come up on the stage. Ms. Michelle Koo, Co-Center Leader, Center of the Age. Mr. Thiratat Ket Choi, General Manager Space Tech Product. And last but not least, Mr. François Xavier Coyer, Senior Sales Manager.
So could you please give a big round of applause to our speaker on the stage, please?
All right. Hello, everyone. Now, this morning we had a very interesting discussion on launching rockets, use cases, and here we're going to talk about how there is a lot of space to thrive in Southeast Asia. And I have a very esteemed panel with me, whom I will introduce in just a minute, but just to set the context on Southeast Asia. Now, the economic opportunity from wider adoption of space technologies in Southeast Asia is very significant. In fact, based on Deloitte's estimates, Earth observation alone is expected to contribute $100 billion to the region's GDP by 2030. And if you're curious about the industry in Southeast Asia, feel free to scan the QR code to access the full report. Now, in our report, we discussed how Thailand, of course coordinated by the great efforts of GISTA, was really a bright spot in Southeast Asia in terms of applying space technologies to benefit life and industry on Earth. So today with our esteemed panel of experts, we'll highlight some of the opportunities of what is happening in Thailand. So my name is Michelle from Deloitte, Southeast Asia, and I will be your moderator for today. Now, just a quick introduction of Deloitte. We have been involved in space for the past 15 years, with over 600 space practitioners operating in more than 140 countries. So we've been serving governments and the private sector on leveraging opportunities in space. So this year we set up two things. Dedicated space practice in Southeast Asia, bringing our global capabilities to the region, which we see as a huge opportunity here, as well as a global downstream center of excellence to help non-space companies explore use cases and develop prototypes that increase productivity or create new revenue streams. So if you want to start applying space technologies, but not sure where to start, feel free to look for us. Now, without further ado, allow me to introduce our esteemed panel. First, and I'll get all of you to also share about some of the good work you're doing. So first, I'll start off with Nicolette Yeoh. Nicolette is the General Manager for the Singapore Space and Technology think tank, and she spearheaded a very exciting transition of the organization from an industry association in Singapore to an innovation engine in Asia. And of course, SST is best known for the most global space convention on the calendar, the Global Space Technology Convention and Exhibition. That Deloitte is proud to be an anchor partner for. So Nicolette, please share a little bit more about the work that you do.
Yeah, so hi everyone, I'm Nicolette and I'm General Manager at Singapore Space and Technology think tank. So we are the first space commercialization space think tank in Asia. So we focus a lot on commercializing space in the broader Asia region. We are the trade association for the Singapore space industry. We were set up in 2006, and we've been building the local space ecosystem for many years now, working very closely with the space companies and helping them to grow and scale through our accelerator program and some other innovation projects. But an important other piece of work that we do is that we really focus on educating and advocating for the use of space technology among non-space sectors as well, as we see space as an important horizontal technology. There's applications in industries across the board, whether it is financial services, climate resilience, environmental monitoring, logistics, automotive, smart city planning. And in Southeast Asia, I think there's a lot of work that we need to do to really demystify space for non-space companies and encourage them to use space as an important competitive advantage. And I'd love to talk about that a little bit more later in the panel.
Thanks, Nicolette. That's really a lot of breadth that you cover. Next, we have Thiratat Kajoe or Kun Kong, General Manager for Space Tech Product at Thaicom. And Thaicom is, of course, Thailand's leading satellite communications company. Now, Kun Kong is a veteran in the industry with a 20-year career at Thaicom, heading up previous portfolios in mobility services and the broadband and mobility platform. But now he's leading Thaicom Space Tech products with very impactful services under the Earth Insights umbrella. So Kun Kong, please share more about your work at Thaicom.
Yes, thank you, Michelle. So my name is Thiratat Kerchui. I'm the General Manager of the Space Tech product at Thaicom. So for Thaicom, we are Thailand's first satellite operator, headquartered here in Bangkok. With the 34 years of experience in the satellite industry. During the first 30 years, we focused on providing satellite communication services like satellite broadband and video broadcasting. In the past few years, we changed our vision to become the leading regional space tech company. And some of the new space tech products and services that we are coming up include first is the geospatial intelligence, which is a fusion of space air-cloud data analytics, helping to extract the actionable insights, addressing different market segments. The second one is on the satellite IoT, which is in partnership with the Global Star, the leading satellite IoT service provider from the US. We have launched Thailand first ground station for the LEO satellite constellation here in Thailand, and we started providing global star services in Thailand and neighboring country.
Yeah, thank you. Really keen to hear more about that later in our discussion. And finally, we have Mr. Francois Royer, Government Export Sales Director of Space Systems at Airbus. And he's been holding this role for the past 6 years. He leads governmental telecommunication and Earth observation satellite sales activities, both for defense and civil, across Southeast Asia and Bangladesh. And he's been in the space industry for the past 17 years. So, Francois, please share a little bit more about what you do.
Very good morning. Thank you very much for inviting me to participate to this panel. I'm very happy to be there. Always a pleasure to be in Thailand. So I'm François Royer. I'm a sales director at Airbus Space System. So Space System is a division of Airbus Defence and Space. We design, build, operate satellite for civil defense and commercial use. We are, in fact, manufacturing satellite addressing telecommunication market, Earth observation, space exploration, and navigation. Talking about our flagship, we have been involved in the LEO constellation program OneWeb, where we delivered more than 600 satellites, which are currently flying in orbit. We are currently manufacturing the second generation of Galileo navigational system for Europe. We are working closely with ESA and NASA in order to provide a service module for the future Artemis mission, the future mission who will go to the moon. And we are also working closely with different organizations, governmental organizations in France and internationally. And we provide telecommunication satellite as well as Earth observation program. So as you can see, we launched more than 800 satellites since our creation. More than 700 satellites are still in orbit. We have a long-lasting relationship with Thailand back to the 90s, where we developed the first Thai satellite called Thai Pass. It was launched in 1998. We launched in 2008 TEOS-1 satellite together with GISDA, and in 2023 we launched TEOS-2 program. And recently we have been awarded by Thaicom for a Thaicom 10 mission. Thank you very much, Thaicom, for that. If we go just to the next slide, I wanted to show you one of our flagship is an image taken by our last generation of satellite Pléiades Neo, 30 centimeter resolution over the international airport of Bangkok, just to give you a flavor of what we are capable to do.
That's amazing. Very long track record in Thailand and the world, and 800 satellites, you say. That's amazing. So let's start off talking a little bit about the market opportunities here in Southeast Asia. And Nicolette, maybe we could start with you. Can you give us a bit of an overview of how you see Southeast Asia's space industry evolving and where Thailand fits within that picture?
Yeah, so for Southeast Asia, increasingly we are starting to see that a lot of the Southeast Asia countries are investing in sovereign capabilities, of course for defense and security considerations. So being able to build and launch satellites that they own is very important. And we're seeing that as a bloc, Southeast Asia is planning to send up 60 more satellites in the next 5 years. So that's huge investment in Southeast Asia. Another big shift is that we're starting to see for Southeast Asia, previously a lot of the space activity was centralized within the government, but now then there's a lot more momentum behind private sector activities as well. So we're starting to see more startups, we're starting to see more companies developing more diverse range of solutions. And there's also more private capital that's coming into the space industry. So we're seeing more privatization as well as space activities. And the final one is, of course, linking back to what you mentioned about the $100 billion economic opportunity. In Southeast Asia, we're focusing more on downstream applications as well of space technology, whether it's communications or also satellite imagery. And, trying to encourage more adoption of these technologies from non-space companies. So these are some of the main shifts that we're seeing. And in Thailand, Thailand is actually very advanced and is a key regional player in Southeast Asia with TEOS 1 and TEOS 2, and then now we have TEOS 3 that's about to get launched. And then there's also plans for a spaceport in Thailand, which will definitely help to spur a lot more space activity in the region. So I think that Thailand is growing, the ecosystem is growing, but also seeing a lot more startups, Thai startups emerging from government support and also more support from private funding sources. So these are all very exciting opportunities that we're seeing in Southeast Asia as well as in Thailand.
Amazing. So if I can sum up, it is moving from government to private sector, from upstream to downstream, and from space to non-space. And very heartened to hear about all the activities in Thailand. And of course, someone who's much closer to the ground in Thailand itself, Kun Kong. What are the biggest commercial opportunities you see today, especially for satellite data and geospatial analytics?
Okay. Yes. So besides defense and intelligence, we are looking at 3 areas. First one is on the carbon credit and forestry. Actually, just a couple of weeks ago, our Prime Minister just announced the new target for Thailand net zero to be in 2050. That is 15 years faster than the original plan. So space data and geospatial analytics will play a crucial role in helping Thailand achieving this net zero initiative target, especially in terms of the increase of the natural carbon sinks. So our product called Carbon Watch is using the satellite as well as AI and machine learning technologies. It's certified by the Thailand Greenhouse Gas Organization or TGO. The Carbon Watch can help the carbon credit project developer to estimate the carbon sequestration in trees as well as calculate the expected carbon credit that they would get registering with the TGO. Some other features of the Carbon Watch would be to monitor and alert on the forest fire as well as the deforestation. The second area we are looking at agriculture. Of course, Thailand is an agricultural country, and the agriculture sector accounts about 10% of the country's GDP. So again, satellite data and geospatial intelligence can help enhancing the operational efficiency of the government agency responsible for different crops. For example, sugarcane, we have worked with the Office of the Cane and Sugar Board in order to launch their satellite and AI-driven platform for detecting the sugarcane field burning in order to reduce the air pollution, especially the PM2.5 levels. So along with other measures to tackle the PM2.5 caused by sugarcane, the OCSB is able to reduce the amount of burnt sugar down to about 15% in the recent harvesting season, comparing to 29% from the previous season. The last area we are looking at insurance. And with climate change and the growing of the natural disaster exposure, the insurance industry requires more precise and up-to-date risk data than ever. So we have worked with the Thai General Insurance Association to bring in the technologies to help accelerating the rice crop insurance claim processing, which potentially can help reducing the processing time by 50%. So those are the areas that we are seeing.
Yeah, amazing. So we're saving time, we're saving costs, we're saving the environment and also saving lives. And I really love how Thaicom packages all these products in a very easy to apply and understand way. Okay, so Francois, how about your side? What are you seeing in terms of concrete examples where industry is making use of satellite data?
So in Thailand, Thailand has always been a leader in the region in terms of geospatial data use, even in the space global industry, especially under the leadership of JITSDA. And thanks to JITSDA, in fact, the use of data has been spread across a lot of organizations in Thailand, starting from the agriculture, as you mentioned, Kong. Thai Rice Department is using satellite images in order to optimize the crop management. Forest is very important, so the Royal Forest Department is using satellite images in order to manage illegal deforestation or illegal logging. As well as a lot of municipalities are using satellite images in order to do urban mapping, do land management, in order to anticipate expansion plan or to develop new road. And also, of course, as you mentioned, disaster management or climate change impact management is very important, and JISDA has been very important organization in order to use those data for floods, for instance, for prediction of floods, early warning measures, as well as for wildfire, especially on the northern part of Thailand, which there was a lot of wildfire which were monitored thanks to satellite images. But I would like to emphasize a very interesting platform that we have developed together with JISDA in the frame of TEOS 2 project, which is called AIP, Actionable Intelligence Policy. In fact, it's a platform which combines space data together with non-space data. And the objective of this platform is to tackle or to address socio-economic problem in order to provide evidence-based recommendation to policymakers. And we are running 2 pilots currently, one in the EEC, so the Eastern Economic Corridor, which is a booming area in Thailand, and we monitor the impact on the environmental and the social way for with respect to the economic development. So we monitor when there is a boost in the economy, what is the impact on the environmental. The idea is to bring a recommendation that can be directly implemented at district and sub-district level for policymakers. The second pilot, which is also very interesting, is located in the Nan province. So Nan province is a traditional agricultural area. And the idea here is to support farmers in order to improve or to improve their income by better managing their land, but with maintaining forest area. So you see the balance. It means, in one hand, we try to optimize farmer income, but preserving the forest. So those 2 pilots are very interesting because they are combining a lot of data coming from space, coming from non-space, and this is directly used for concretely on the daily basis by the policymaker.
Right, so a lot of rich examples you shared there. I suppose concurring with Kun Kong on the environmental deforestation aspect of it, but you also highlighted some of the urban use cases as well in terms of planning and even improving lives and income while also balancing the environment. So I think that's a good point to then talk about the technological innovations that have allowed all of these use cases to happen. So perhaps Nikki, back to you in terms of what kind of technology trends you have seen in the industry.
Yeah, thank you. I think for satellite imagery, there is a lot of applications of artificial intelligence to be able to process satellite imagery quicker and to provide those insights that makes it accessible and usable by end users. So AI paired with satellite imagery is a very big trend that we're seeing. We're also starting to see a lot more edge computing investments so that satellite imagery onboard satellites can process the imagery on board before downlinking, so that results in lower costs and also becomes more efficient in the process. The other thing that we're seeing is also increasing intersection between different deep technologies and space. So quantum is a big one, where quantum key distribution paired with satellite communications can actually help to improve the security for satellite communications and secure our communications. And then I also wanted to talk a little bit about a change in business models as well, which is important in helping make satellite imagery more accessible to end users. So we're starting to see, instead of having to send out big satellites or to commission satellites in a very big project, we're starting to see this new trend of insights as a service, where companies that want to just start getting started with EO adoption can actually subscribe to analytics platforms on for example, a SaaS model, so that it's easier for them to get the actionable insights and the analytics without actually having to invest so much money into developing a satellite or tasking a satellite in a big way. And this is a very important shift that we see will allow for more non-space companies to adopt EO technologies. I think this is an important one that can help our space industry grow quite fast as well.
Right, so there's actually almost no barriers to entry for any of us to get into space, right? It's easy to get started. We can make use of some of the readily available information, and it's all about the human imagination, I think. So then maybe for Francois, in terms of technology, of course, Airbus is very much a technology company when it comes to the satellite industry. What are you seeing there in terms of emerging technologies?
So if we look back to the last 10 years, in fact, the small satellite technology has evolved a lot. A lot of initiatives are popping up. On the telecommunication satellite market, first of all, you saw a lot of LEO constellation, OneWeb, Kuiper, Starlink, but also on the Earth observation market, many of new space companies are coming and are proposing and launching satellite solution which provide a large amount of data, and it provides something which is quite interesting is high revisit, but sometimes the revisit is at the expense of the resolution. And this is from Airbus standpoint not the way we are addressing the market. We are more focused on the high-end market. We are focused on very high resolution satellite imageries with very high quality. This is why we launched a constellation of 2 satellites, Pléiades Neo, 30 centimeters, that you saw the picture previously, which is a complement of this new space initiative. But all those initiatives coming from SmallSat, from this evolution of the technology, provide a lot of data. And for that, you need ground-based solution in order to process them. And this is where AI is coming. And we need artificial intelligence in order to process the data. I mean, we need AI to digest millions of square kilometers every day to extract interesting information, insight. And we need also AI to predict the impact of the climate change based on satellite images. We, for instance, on our side in Airbus, we are using AI in order to improve the resolution of our images without creating artifacts and false information, because it could be the trap of the AI. You need to be sure that when you are using AI, you do not jeopardize the information, the core of the information. And then what is also, I think, very important with AI will be the capacity to merge or to integrate space data to non-space data in order to create actionable insight and business insight. And if you create business insight, I think you will open up opportunities for business, for industry, to leverage the use of geospatial information for operational efficiency and sustainability. So I think that as the technology will evolve, we will see the geospatial market will transform, but this transformation will lead and will drive innovation, and at the end will create more value for the overall society.
Yeah, so if I can just capture some of what you said, I suppose one is the resolution, right? And you were talking about this image. And what's the resolution on this image?
This one is 30 centimeter native, so it's coming like that from space, and we are able to improve it to 15 centimeter.
15 centimeters.
1.5, yes.
1.5, amazing. So you can actually see even some of the small trucks and small containers there on the airport. And of course, in the past, you would need to have a whole army of people to analyze all of that information. But then you're saying now with AI, all of that can be done, quickly. Even while we sleep, it is monitoring and giving us the insights, and also giving us the ability to combine space data with non-space data, so you get even richer insights. So Kun Kong, I think with Thaicom as well, I think you're bridging the gap from what data we receive from the satellites to translating that to very effective services and use cases for clients. So perhaps I'll get you to weigh in on this technology discussion as well.
Okay, thank you. So for us, AI and machine learning, again, is the real game changer, allowing thousands of images to be automatically processed in near real time. That is huge. In addition, the ability to be able to process the multimodal or data fusions analytics, for example, to the combination of complementary Earth observation sensors as well as non-Earth observation sensors, also provide a very powerful actionable analytics or insights to the customers. So I think that is the most important one.
I think what Francois mentioned about the predictive analytics is a very important shift that we're starting to see, because being able to monitor weather patterns and draw trends from that allows us to actually take a more preemptive approach to understanding the damage that could be caused by natural disasters, which is a big thing in Southeast Asia, which will allow us to improve rescue operations and also reduce costs that is associated with natural disasters. So I think the shift from reactive to predictive that is driven by AI technologies and sophistication is very, very important as well.
Yeah, that's a great point, Nikki. And I think what's clear from our discussion is that the technology is there, the data is there, the talent is there. But then I think earlier we were also having this conversation that convincing a lot of commercial organizations to adopt these technologies is actually not that simple. Kun Kong, maybe I get you to weigh in on what do you think are some of the barriers to adoption?
For us, there are three. First is on the costs, and this is a bit more of a chicken and egg. The supply of the usable satellite imagery still remain limited in our region because of the demand is still relatively low. On the other hand, the demand is growing slow because of the data isn't consistently available or affordable enough in order to build a very strong business case. So without achieving the economy of scale, it will be very difficult to bring down the costs to the level that satellite-based solution can fully replace the traditional one. The second one I would say is in the gap in the understanding of how the space technology can actually do for the industry. And some people might imagine about the futuristic or the action movie use cases, while the other may just associate it as something like a Google Maps. So there's a huge gap there. So I think what we all need to do is that trying to keep educating our customer of the use casing, doing demos, POC, so that they are better understanding of what the space technology can produce. And lastly, I think it's all about the accuracy of the models themselves. International or global model may work perfectly fine in their home country, but they yield low accuracy in another. So I think this model need to be trained with local data in order to come up with the best accuracy that is acceptable by the customer.
Yeah, I actually find your comments quite heartening in terms of how we do need that local services to come in to lower the cost, to improve the accuracy. So there are opportunities for all of us here on the stage and of course everyone in the audience. Francois, maybe you want to weigh in a little bit on the cost and the awareness aspect. What more can we do or what more should we be doing?
Yeah. Awareness is a very important element, as you mentioned, Kong and Michel, because there is a lot of industry which are using satellite images. Nestlé is using satellite images to monitor to be sure that the supply chain is procuring palm oil without impacting the forest, or that does not come from deforestation. A lot of oil and gas company, Total Energy, Shell, Repsol, and so on, are using satellite images to monitor the infrastructure and oil spill. And it's true that Earth observation data hold a significant cross-sector value. Yet, a lot of industry are not aware about it. They are not aware about the potential. And why? Because I think we don't speak the same language. I mean, we need to be sure that the technology is accessible. We need to, in fact, to speak with what is of their interest. We need to work on business insight. In fact, what I like to say is that we need to turn pixels into decision. I mean, so to unlock this potential, I think there is three actions. The first one is to understand the value chain of the industry, and each industry has its own value chain, so it has to be specific, it has to be tailored. The second one is to build business insight. So having this platform, such as the AIP one that we were mentioning previously, having specific application developed by startups, funded by the government in order to be accurate and to provide what is the third element, return on investment. If you speak about into industry, you need to speak about return on investment. It could be tangible, it could be intangible, but you need to mention the ROI, and it's related, of course, to the cost. So to foster a wider adoption of space data to non-space industry, then we need to start to speak the same language, to understand where is the value, to make the technology more accessible, awareness, communication, seminar, such as the one that we are currently running, and also a global framework policy locally in order to strengthen PPP approach. Public-private partnership is the key. Governments need to boost startup in order to innovate, in order to deliver useful application for the industry, and to create a sustainable ecosystem.
I think that's a good segue to Nicolette to talk about ecosystem and how do you think we can harness the ecosystem in order to overcome some of these barriers?
Yeah, I think when you want to create a very strong industry, you need to harness the power of different stakeholders. You need to get everybody on board and to encourage collaboration. So if I take an example of Singapore, for example, there is a very strong startup ecosystem. There are a lot of younger companies that are developing new technologies, developing new payloads. And then they need to work with investors. So investors are a huge part of the ecosystem as well, because without funding, the startups will not be able to scale. And so then there's a lot of work that needs to be done on the investor side as well, because investors that are new to investing in space tech, there's a lot of misconceptions or challenges that they have in making some of these investments or making that leap to consider space technology. Because for space tech, it seems like it's always very long tail. You need patient capital, and some countries, the investor ecosystem is just not at that stage yet. And so startups, investors, and then academia is really important as well, to be able to partner with the companies to translate research that's happening in the universities and take that out and commercialize them into companies. And then, of course, having regulatory policy that can support the startups, giving grants, encouraging them to, participate in larger government projects so that you give them a bit of a boost. These are all important building blocks of the ecosystem. And I think ultimately the key is really that collaboration is super important, especially in the space industry, right? Because in space, there are no borders at all. And for space, because it's so complicated, no one company or no one country can, do the entire value chain. And it's important to understand what countries are specializing in, what they're good at, and then partner with other countries or partner with other companies to support that. So joint innovation, joint research projects are all very important. And I think one more thing, going back to the point about investors, Singapore is a capital hub, a financial services hub, and there is more interest in the deep tech investors wanting to explore space tech. So I think that there's something there that we can do to, connect the Thai ecosystem, the startups that are in Thailand, to more investors overseas as well, whether it's in Singapore or, the larger Asia region, so that we can actually give them that boost and help them to grow and scale. So these are all things that we need to do to ensure that the industry can continue to grow in a commercially sustainable manner. Yesterday I was on another talk that said that the definition of ecosystem means that it has to be self-sustained. There needs to be the right key ingredients, the right foundation, so that it can continue living on for many years and many decades to go. So having all of these stakeholders coming together to work together is very important.
I love that. Really having the whole ecosystem to come together, which is also what we're doing on the stage here. And, as the saying goes, if you want to go far, we go together, right? And we're trying to get to the moon and Mars. So, thank you so much for all the deep insights you've given from many different angles in terms of the Thai space industry. And so I think just one final question to each of you. If we look 5 years ahead, what would success look like for Thailand's space industry, and what needs to happen for us to get there? And of course, we will get our representative from Thailand to weigh in on this first.
Okay, so I think success for Thailand is when we develop both upstream and downstream capabilities, not as an adopter, but as a supplier, exporting our own technology and solutions to contribute to the space economy, just like what we have done in the past with the telecommunication satellite with our Thaicom 4 IP Star, which is the world's first high throughput satellite. And in order to get there, I think I totally agree with Fong Shu and Nikki that first thing first, the government investment and policy need to focus on strengthening our national space technology capability. For example, by building upon the country's existing strengths, fostering partnerships with other countries, as well as creating an environment that attracts the global talent into Thailand.
Very, very nice. Very excited to see that vision for Thailand. Francois, how about you? 5 years from now, where do you think we should be?
First of all, I would say that Thailand needs to continue this space trajectory. This is the right direction, definitely. You see public organization working with commercial organizations, so the foundation of the ecosystem is there. So I will say in 5 years, I will expect a mature downstream market fueled by a new upstream manufacturing satellite market. So I will encourage international cooperation. I will encourage the development of local space technology, but built on existing solution. Do not reinvent the wheel. We are a lot of exhibitors who can show very good technology, so we can build on top of this technology. So no need to reinvent what is already existing, because after you spend too many costs. And also, what is very important to make it sustainable is a budget. there is a need for the government to inject a significant budget over the years in order to be sure that this trajectory, that this ambition is met its objective. And then, as I mentioned previously, we need this policy framework which strengthens the public-private partnership.
Very well said, Francois. So last but not least, Nicolette, over to you.
Yeah, I think if we look at the private sector and for startups that are starting to emerge in Thailand, obviously the ambition really in a couple of years' time is that you get very successful startup exits, whether it's IPOs or acquisitions. And I think having these really strong success stories will then help to encourage even more startups to emerge and even more startups to be heartened that there is this future ahead of them for them. And in Singapore, we are working on this. A couple of our companies are already raising bigger institutional rounds for Series B, Series C. But yeah, I think if we have successful exits for space startups, that would be one big one. And then the second one, I think, is also about encouraging more investments into the ecosystem, getting more family offices in Thailand or more private equity companies investing into space companies and into the space industry so that we can have the right ingredients to grow and to scale. And I think lastly, when we're talking about downstream applications, I think the dream is really that it's not something that we need to explain and educate anymore. It's kind of really taken off and it has its own momentum of its own. People understand space technology. Every company has space integrated into their corporate data strategy. That will be a really important win for all of us here because I think that's our mission here is really to encourage more usage of space tech among all of these non-space companies.
Amazing. So really, if we all come together, there is plenty of space to thrive in Southeast Asia. So let's work together to help the Thai space industry on the rise. So please give a big round of applause to my panelists. Thank you.
So thank you very much, Ms. Nicholas, Ms. Michelle, Mr. Fongso และคุณธีรทัศน์นะคะขอบคุณสำหรับเซสชั่นที่ดีงามมากๆเลยค่ะ
Yes, exactly. Thank you very much, all panelists joining us on the stage. Crucially, you know that our past discussion is going to be the Southeast Asia space industry on the rise. But up next, coming on the stage, the session is very interesting because we're going to keep on the Southeast Asia.
Which angle in Southeast Asia?
It's about the opportunity.
Wow.
The word opportunity is very important for every industry, especially space industry. เอาแหละนอกเหนือจากนี้ที่ผมบอกเลยนะครับ discussion ของเรา panel ต่อไปเนี่ยก็เป็นหัวข้อหนึ่งที่สำคัญเมื่อกี้ panel เมื่อกี้เป็นเรื่องของการพูดคุยในเรื่องของธุรกิจอวกาศรู้จักไหมคุณธุรกิจอวกาศ
โอ้โหจริงๆมันเป็นเอาจริงต้องบอกว่าเป็นเรื่องที่ค่อนข้างไกลตัวนิดนึงค่ะแต่คือมาวันนี้ก็เป็นเหมือนก้าวแรกเป็นสเต็ปแรกที่ได้เรียนรู้จัก
เขาว่าห่างแค่เพียงเอื้อมมือ แต่ก็คือแสนไกล
ใช่ค่ะ
แต่ไม่ไกลแน่นอนเมื่อคุณมาอยู่ที่นี่ Thailand Space Expo ธุรกิจอวกาศคุณเนี่ยห่างแค่เพียง1เล็บครับนั่นเองใกล้ๆเลยฉะนั้นรอบๆที่ผมบอกเลยตอนนี้ถ้าใครเนี่ยเขาเรียกอะไรคนที่เข้ามาร่วมงานของเราตอนนี้เนี่ยอยากให้เดินรอบๆงานของเราไม่ว่าจะเป็นด้านหลังของฮอลนี้โซน exhibitor ต่างๆมากกว่า30 exhibitor จากทั่วประเทศทั่วโลกเลยดีกว่านะรวมถึงท่านไหนเนี่ยอยากสนใจธุรกิจเกี่ยวกับอวกาศนี่โซน business matching อีกหลากหลายเลยซึ่งด้านหลังเนี่ยผมได้ข่าวว่ามีการเวิร์กช็อปด้วย
ถูกต้อง
คุณอยากขึ้นยานอวกาศหรือเปล่าแบบ stimulate
ก็น่าลองดูสักหนึ่งครั้งค่ะ So I would like to invite and encourage everyone to take a tour around our exhibitor booth just behind the hall so you have a chance to explore many new things in our event.
Yes, moreover the 30 exhibitor around the world, the workshop area and especially the business matching area as well. Just explore them in our Thailand Space Expo 2025. And this is the very first day from total 3 days. Ladies and gentlemen, upcoming on the stage will be the session of the Space 3.0 Opportunities for Southeast Asia. Ladies and gentlemen, please give a big hand to Miss Candace. Come over the stage.
Let's welcome.
Hello. It is so nice to be here in Bangkok, in Thailand, where space is on the rise. I just arrived from Bahrain, where I was also helping the Bahraini Space Agency. And, you know, for me, having helped create SES from Luxembourg more than 40 years ago, it is so beautiful to see these emerging spacefaring nations. And I assure you, it's only getting started now. I wanted to, and it's very nice that we are able to talk after this excellent panel. I always tell everybody that my life has been using space first to provide universal access. So with SES, it was satellite television, satellite telecommunications. With Iridium, it was satellite mobile communications. With Europe Online, it was the first broadband internet satellite network. With ILS, International Launch Services, it was the first joint venture between Russians and the United States to commercialize Russian launchers. And so from using space to provide universal access to then accessing the universe. So now everything that the panel just before was talking about, which is, you know, the Earth observation, the monitoring of our environment, the climate, the looking at the gas and pipelines, the looking at the methane, looking at the rice, at the, you know, how is the rice affecting our climate, et cetera, and then going to now what I call networks for the universe, or space 3.0. And, you know, today, space is really related to everything. And the reason for that is pretty much because of IoT, Internet of Things. Sensors are on everything. And what people also don't realize is that every single financial transaction, electronic financial transaction that you do, is powered by GPS. We're seeing also space and space technologies. Very, very important are robotics, quantum, which was talked about, but quantum not only for QKD, but for quantum communications, quantum simulation. And my dear friend, you know, Vint Cerf, the father of the internet, he's always telling me, Candace, yes, there are things that happened with the internet that I did not foresee, but we must all work hard to promote a positive digital transformation. And, you know, I'm so excited to be here because I think that Southeast Asia has the opportunity to become the Space 3.0 center of the world. And, you know, I'm also very proud to be a council member of the Singapore Space and Technology think tank. And, you know, I'm always urging everyone, don't copy what has been done before. Build something new. And so when I look, and I was thrilled to have the gentleman from TICOM to, you know, to talk about the fact that he's working with upstream and downstream, because I think that this is really a trend that is so important and that can be done in a new way. You know, then also combining orbits, LEO, MEO, GEO, new orbits, space-based networks, on-orbit edge computing, internet, data relay, sustainable space, space debris, all of these things, and of course microgravity, these are the areas where I think these emerging spacefaring nations can really do something. And Southeast Asia, because you are so good in manufacturing and in chips, I want to talk a little bit more about the chips later on. I thought it might be helpful for you. I'm the chair also of Seraphim Space Advisory Board. We are the world's largest space and space tech fund. And I just wanted to give, it's so funny. I have never ever done a government-sponsored project. I have always only done what people call new space. And I've been doing that for 45 years, always commercially oriented, privately financed, and market oriented. And, also I was kind of thinking about the panel beforehand and getting people to adopt space technology. You don't want to get them to adopt space technology. You want to get them to adopt what space technology can do for them. And I remember when we were first starting SES and everybody was showing a ground station that went up to a satellite and came down to a terminal. We didn't do that. What did we show? We showed a panel of 16 television channels. That's what you could get if you invested or got an Astra dish. And so I think it's important maybe just to share a couple of numbers with you, because for me, and I think for everybody, you should always have a business plan. My dad made me do business plans when I was 5 years old for my lemonade stand. So, you need to do a business plan. And so also here, what is very important is what also I think Nikki said, is that, deep tech investors now are looking very much at space tech. And so we're seeing this incredible growth in investing in space, which will probably actually even be larger than AI. And some things are happening, particularly with the Earth observation technology. Of course, if you're looking at rice fields and weather and oceans and being able to have high resolution, well, you can also do that with dual use defense. You can track tanks, you can track troops, and so we're seeing a renaissance, really, of defense use of space. Now, I say renaissance, for a lot of people, they don't know, but, my father was one of the first people to do the first satellites for the United States government. He was a general in the United States Air Force. And so I've seen this trajectory, this pendulum, where space was only used for defense, to then the commercial people coming in, and now we are having the two of them together. So, and also, whereas at the moment, defense is taking really the kind of higher part of it, all of this is going to help the climate applications of space, the Earth observation. And so, here, this is a market evolution. So, first we had the space 1.0 with, television, telecommunications, internet. We're now having large constellations of space, of satellites. We're having real-time insights, as our friend from Airbus, was saying. And now we're at space 3.0. So we're looking at space-based networks. We're looking at sustainable space. We're looking at microgravity. But I'm also looking, and I'm calling it 3.0 too, space-based solar energy, lunar resources, and real estate, commercial space stations. So very exciting. People talked about funding and people talked about investing. But the fact of the matter is, it's always investing. If you're doing R&D, it's funding. But if you are doing business, in space, it is investing. And we need to have returns on investment. And I always tell this story that when we first started SES, we had all of these bankers. And so they got together and they said, since we're investing in this company, we've got to make certain and have a return on investment. And they were fabulous because they put together that Luxembourg model. So just to go back there, I think I can, yeah. So last quarter, we're very excited about this at Seraphim. We had $8.7 billion invested just in the last 3 months. So we really are on that trajectory to get to about 1.8 trillion in about 2040. This is an opportunity for everybody, not only to invest, but to use space to increase their profits, to create new products, etc. So, and I like to, people always are kind of putting things in boxes. I like to be barrierless. And certainly I think that the finding of the James Webb, telescope have led to one space. So beforehand we used to talk about deep space, near space, and the planet. For me today, I just talk about one space. And therefore we are using space to protect our wild regions with the detection of forest fires, to preserve our rivers and our oceans, to also in space predict orbital collisions, to have environmentally safe exploration on Earth and in space, definitely to secure the world's food supply, and of course doing hyperspectral imaging that lets us take an MRI of everything that we are doing on space, on Earth, from space. And, it's also not only one space, it's fast space. And that is why also here in Southeast Asia, you have the opportunity to go fast. You do not have legacy networks. You do not have legacy processes. You can just say, oh, I'm going to do a launcher. And you can do it at 1/100th the price of what it normally would be. And it would be small, and it could have small satellites, or it can be big. So, it's a question of getting into space quickly. That is your competitive edge. And also, as I think it was the gentleman from Airbus was also saying, you don't have to reinvent the wheel, but you can. There are today with software-defined processes. A gentleman came up to me yesterday in Bahrain, and he said, I'd like to build a satellite. I said, fine, just go to the internet. You can find at least 10 companies who will sell you the components to build a CubeSat. It's done. So also, the fact that we are seeing then the blurring between the various orbits. But I do want to come back to the fact about being profitable. If you do not have revenue, if you do not have profit, you will not survive. And so we have to get from the beginning, we have to have this mindset about being profitable, about doing space because it's good business. And that is 3.0. And so I always say that, there are two things that you can pretty much boil investing in space or working in space to. It's the bang for the buck, and it's defying and using gravity. Okay? Defying and using gravity. And so, for the bang for the buck, and this is, I'm very proud also, if I may, to ask Ambassador Hemmer from Luxembourg to please stand up. Yeah. Thank you so much, Ambassador, for coming today. But you know what? I mean, as we all know, space is absolutely Luxembourg's priority. So it's important for you to be here. And I'm looking forward to seeing some of the companies that you talked to me about as we go through the exhibit that are interested in working together with Luxembourg. But, you know, somebody talked about, I think it was Nikki, she talked about Singapore being a finance hub. Well, you know what? Luxembourg was a finance hub. And so here again, when you're doing something and you use what you have. So what did we have in Luxembourg? We had banks. In 1983, 1984, there weren't any venture capitalists in Europe at all. But we had banks in Luxembourg. And the prime minister said to the banks, can you invest in this private space project? And if you do, we will look kindly on your Finanzplatz in Luxembourg. And you know, the fun thing is that they never really expected to make any money. Well, they made billions, literally. And more importantly, they learned how to invest in space. And they learned how to invest in deep tech. And that was really, I think, the biggest lesson for them. Why did GE get into space? GE Capital. Because it was good business. They loved having all of these satellites that they could lease. And Jeff Bezos, Peter Platzer, Matt O'Connell, they were all Wall Street bankers, okay? So this isn't just, you know, research and development. This isn't being, you know, doing your SDGs, which, by the way, space actually does fulfill all of the UN SDGs, the Sustainable Development Goals. It is about making and creating value and extracting value. And, you know, here, this is really where I see this defying and using gravity. So, you know, space in space, you know, is, you know, 4 years ago, we at Seraphim, we had a meeting together with our advisory council, and you know, and the CEO said, Candice, do you think space in space is going to happen in 10 years? I just looked at him and I said, no, Mark, it's happening right now. Today, at Seraphim, we are doing more than 50% of our investments in space in space. So, you know, and also one thing that I'm kind of really, you know, everybody talks about LEOs, but and I did the first commercial LEO with Iridium, but my heart really does still be in GEO. And so I'd like to call that Space 3.0 as well, because, you know, LEOs are actually very inefficient use of bandwidth. And they, you have to refurbish them or relaunch them every 5 years, etc. They are shared bandwidth; they're not dedicated bandwidth. Whereas GEOs, you know, GEOs, you can have 3 GEO satellites and you can cover the world with them. And then with these dedicated spot beams, you can be very, very, really competitive, even with the latency with LEOs. And I think that GEOs will be given a whole new life because we're going to use in-orbit processing, in-orbit fueling, 3D printing, etc., to create new, basically to use them as a platform for new observations, for solar panels, etc. Obviously, space stations will be built in space. We're not going to send them up. We're going to, and here again, so we're defying gravity, we're using gravity. And of course, all of the advances in energy, medicine, agriculture will be used, you know, will be done by using microgravity and weightlessness. And certainly the digital transformation, so just as we are having space use and enable the digital transformation itself is also absolutely bringing about low costs in launchers, low costs in satellites, and also this is why I say Southeast Asia, you with your chip manufacturing, with your new energies, your advanced materials, this is an area where I really believe you can shine. We can just go on with that. So also very important. We have clouds on Earth, but Space 3.0 is also about having clouds in space. And we'll talk a little bit more about that. I'm very excited about space-based data centers, so space-based data centers. And indeed, when we have those space-based data centers, we do need certain chips that are not affected by radiation. And here again, one of the companies in Singapore is working on making those radiant, shall we say, defiant chips. And really almost all of the, SES were doing clouds with with Azure Soft, with Microsoft with Azure Space. Amazon, quite frankly, even if they had no clients for Kuiper, they would just have all of their clients internally with their Amazon web stations. And now, of course, we do have to talk about defense. It is driving today, no question about it, the investment in space. And, whether it is for surveillance of the Earth and then intelligence, gathering the intelligence, whether it is actually having space wars in space, where we have satellites from Iran, China, North Korea, and Russia, who are basically casing the Allied satellites and can actually even take them away. And of course, we've got cybersecurity. So everything, people talk about, oh, well, we're fine. We have cybersecurity on our ground stations. No, you have to have cybersecurity on your satellite, particularly if you're doing on-edge computing and etc. And another thing that I'm very, very concerned about right now, and I'm working on, is what I call the colonization of space. And that is because, and that's why I'm hoping that all Southeast Asian nations will make certain that they use their orbital positions and their frequencies, and that they do it for what they want to use the satellites for, not for what somebody else might be telling them. Okay, and I'm going to say Elon Musk, I'm going to say particularly Elon Musk, because I'm very worried that with his Starlink, he is actually taking away bandwidth, frequencies, orbital positions from emerging spacefaring nations, and he's assuming that they want to use it for connectivity, which, as I already said before, is actually not a very good connectivity because it's a shared connectivity, a shared bandwidth, but another country may say, well, no, I want to use my frequencies for Earth observation or for, laser to ground, etc. So, please go out there and do your space programs. And so anyway, I did a manifesto for a clean, safe, equitable, peaceful use of space. And believe me, if we're talking about Space 3.0, we need to make certain that this is really what we are going to, that we will have enough space. And so here, just kind of getting near the end of my little talk here, my tips for investing in space. A lot of people pay a lot of money for this. I give it away free. Space in space. In-orbit manufacturing, in-orbit services, robotics, 3D printing. All of this is happening today. You would be amazed. And I have a friend who's an architect. He's architecting habitats for space. Guy Trotti, he's just a lovely, lovely person. Multi-orbits, don't get stuck in this rut about geo, LEO, MEO. That's not the important thing. You have to say, what do I need to solve? What is the problem? And how can I best solve it? And sometimes it may not even be space. Usually, though, I tell everybody it may start in space, but it may not end in space. And then something that we have a very, very big problem with right now are launchers. And so, it kind of breaks my heart because I did work so hard to put together the ILS, the International Launch Services Company, which for 10 years, from 1995 to 2005, was the #1 launcher. And of course, we are not working with the Russian launchers at the moment, but maybe we will some other time. But in any case, we need Avril or Kourou or Baikonur. The launcher companies are small. The satellites are small. You can just have your own launch, or you can do the horizontal launchers. And obviously, we need to have more launchers. Even if we have one launcher and we're saying, SpaceX, SpaceX, SpaceX. Look at Leo Labs. Somebody just the other day said, wow, I think I'm going to invest in Leo Labs because they're obviously doing very, very well. And there will be many, many other launch companies, private launch companies, who will be able to bring satellites into space. Software and onboard processing, space stations. Here again, it doesn't have to be the ISS. It can be a habitat in space. It can be a lab in space. It doesn't have to be huge. So regional connectivity satellite systems, like the one that Thailand is doing, or also I'm very proud to have helped create another regional connectivity satellite system called Pacific. Space-based solar power. We anticipate, if we get this right, that we will have 20% of the world's needs by 2040 from space-based solar power. And really, just think about it. The satellites up there, they have the solar panels. We're just going to have huge farms of solar panels, and we're going to bring down that wonderful space solar power via microwave to the grid. And this is not rocket science. It's actually kind of happening now. And then, of course, space exploration and space labs and space experimentation. And I do want to talk about the new materials, the new energy sources, the batteries, and the chips. When we started SCS Astra in 1983, at the time, everybody thought you needed to have all of the power in space. And so they were all of the competitors were doing satellites that had 250-watt traveling wave tubes. We knew of a development in Japan that was using gallium arsenide for the LNBs, for the outdoor receiving equipment. And with gallium arsenide, it was 10 times more performant than the existing LNB's outdoor receiving equipment at that time. So therefore, we did not need to buy or produce satellite that had transponders with 250 watts. We produced it with 25 watts, and we had the same performance. And talk about investing and ROI, just think of putting 16 transponders on one satellite for $90 million, or putting 4 transponders on one satellite with 250-watt transponders for $1 billion. Okay, just do your math. Always just do your math. The bang for the buck. So, and just to kind of give you some pictures here, it's always kind of fun. I think, for Southeast Asia, what is going to be very important for you also is that you will be able to have laser to satellite and back communications. In many parts of the world, we have the cloud cover, and so that is not so good. But here, this is a real opportunity, and optical communications with satellites are getting increasingly very interesting, and we need to have them because they are 100 times more performant than frequencies, radio frequencies. And then this is here again, this is the regional satellite that I was talking about. And you see, for every single island, we had a dedicated beam. And that dedicated beam allows that satellite company, Pacific, to do SLAs, service level agreements, so that we can absolutely provide to our users a service level agreement that they will get this amount of bandwidth, this speed, this latency, for what they pay for. So, and fun, I see some women in the audience. So actually, the first investors in that Pacific satellite system was a group of women, Oceania Women's Network Satellite. Men are not allowed to invest. It was just women. And we had a great time doing it. Then, funnily enough, but it's not really that I'm always doing it. But I think that I want to inspire all of you with your Space 3.0. This is the exploration company. It is started by a friend of mine, Hélène Huby, who was my protege 10 years ago. And she's building the first space station made in Europe. And she already has flown. And she's doing amazing things. And she just started it. So she's basically taking, so it's like a space station, but it's much cheaper. So she's actually doing the manufacturing, she's doing flight heritage, she's doing pharmaceutical cells, etc., in her little space station. Now, and here's another friend of mine who also happens to be a woman. And by the way, I think that is Space 3.0. I was at the ITU just 2 weeks ago. The head of the ITU is a woman, Doreen Bogdan-Martin. The head of UNOSA, United Nations Office of Outer Space, is a woman. We're getting there. It's kind of fun. So this company, Interstellar Lab, they build modules to grow plants on Earth and in space. So the founder is a woman named Barbara Belvisi, and she is the she won the NASA Deep Space Food Challenge, and at the same time she's also building modules for L'Oréal for them to grow the plants that they need for their perfume. So that's pretty cool. And here's just an artist's rendition of what the space-based solar power looks like, but it looks exactly like that. So just imagine, large solar farms, but in space, and bringing down that energy. Clean energy, by the way. And then, of course, the moon data centers. A number of companies that I know are working on moon data centers. I think that this is going to be huge. We cannot, and here again, this is an area that Southeast Asia can really work on because it assures sovereignty. You don't have the problem with the privacy of data, etc. And if you don't have a lot of room or land, and if you have and for the cooling, with the water, etc., space-based data centers, I think, are the future. So thank you so much. I will be around here if you have any questions, and it's lovely to get to explore, as our friends are telling us, to explore the exhibition and this wonderful, exciting region that is doing great things in space.
Thank you very much, Miss Candace Johnson. But she will stay around here for 3 days, right? 3 days. If you have any question, you can ask her directly for the question you guys want to know. Because here is the Thailand Space Expo 2025. And today is the very first day from total 3 days in a row. From 16 to 18 October 2025. Stay with me, Top and Cherry as well.
ค่ะและงานของเรานะคะยังอยู่กันตลอด3วันนะคะ16ถึง18ตุลาคมนะคะแล้ววันนี้เป็นวันแรกแน่นอนค่ะกับเซสชั่นในช่วงเช้านะคะความรู้เยอะแยะมากมายเลยเราได้จบลงตรงนี้ก่อนแต่ช่วงเย็นวันนี้ค่ะในเวลา 17 นาฬิกานะคะที่เราจะมีพิธีเปิดงานอย่างเป็นทางการอีกครั้งหนึ่งร่วมกันยังไงอยากขอเรียนเชิญให้ทั้งเหล่าบรรดาพี่ๆ exhibitor เองหรือว่าผู้เยี่ยมชมเองนะคะอยู่กับเราก่อนนะคะ
So up next, we will break on the stage for a while. I will see you once again 5 p.m. in the huge opening ceremony. But at this moment, you guys can hang around over here to visit many booths, talk to all exhibitor, and also workshop as well in the rear of this hall. And outside of the hall, there is our lovely sponsor as well.
ค่ะและงานในครั้งนี้ก็แน่นอนนะคะจิสดาของเรากับสำนักงานพัฒนาเทคโนโลยีอวกาศและภูมิสารสนเทศนะคะรวมถึงกับเจ้าภาพทั้ง5องค์การนะคะ JAXA PTT CP EGAT และไทยคมเราได้ร่วมจัดขึ้นมาแน่นอนสวยงามมากๆกับ3วันที่กิจกรรมแล้วก็หลายสิ่งหลายอย่างค่ะเป็นเรื่องราวอวกาศในปี 2568 ที่อัปเดตมาล่าสุดเลยจริง
Ladies and gentlemen, throughout these 3 days, it wouldn't be possible to create the amazing event like this. I would say thank you very much for the GISDA and also our lovely co-host, JAXA, PTT, CP, EGAT, and TAICOM for supporting us. Thank you very much.
ค่ะและตอนนี้เดี๋ยวเราพักเวทีกลางตรงนี้กันสักครู่ก่อนแล้วเดี๋ยวเรากลับมาเจอกันในเวลา 17 นาฬิกาค่ะ
And we will see you once again on the stage 5 p.m. in the opening ceremony session. Right now, let's take a break for a while and see you then.